Hey guys, David here and welcome back to the series where I build a new CNC machine from the ground up. Here you can see the result from the last episode where we have built all of the aluminum plates and I machined those on my Radric Killer Bee. Now in this video we're gonna start assembling everything. I start off with the servo motors here. These are 400 watt Leadshine Servo Motors that were graciously sponsored by Leadshine. So big thanks goes out to them, and I will have all of their stuff linked down below. So what I do here is start mounting these Leadshine servo motors to the motor plates that we machined. And these will allow me to tension them against the belts. They just very simply screw in some threaded holes with some M5 fasteners. Now I chose the 400 watt servo motors as they have a very similar footprint to the NEMA 23 stepper motors, which I first decided was going to go with. And 400 watts for this kind of machine is probably on the lower limit, but I think it should still be fine. You can also see that one of the motors is slightly larger. That's the one for the Z-axis, and it includes a brake. That's just so that the Z-axis does not kind of creep down if the machine is not powered. It might not be strictly necessary as my Z-axis is not that heavy, but since I was just getting the motors and they asked if I wanted a brake, I said why not? And it certainly doesn't hurt anything. It will just be, the brake will be turned off with the enable signal to the drive. So whenever the drive has power, the brake is off, and when the drive does not have power, the brake will be on. Next, I'm assembling the motor brackets for the Y-axis. They include the mounts for the servo motors as well as where the lead screws are attached. And in between there, of course, is then going to be the belt. I'm using the FK ball screw blocks here, which are slightly different to the BK blocks, as in that they are flanges that mount to the face instead of to the bottom. It just makes it a lot easier to mount in here. I'm also using for these bearings as well as for the ball screws themselves, I'm using C5 grade, which is a bit better than just like your standard generic one. For the bearings, that means that there are angular contact bearings, which you really need for this kind of application. And for the ball screws, they're just actually meant for precise motion. But do make sure that when you are buying ball screws, the kind of generic ones that don't have any grade labeled are probably not actually meant for precise linear motion, but just for moving stuff without a precise interval. So C5 is really kind of the minimum you want, and also usually what the maximum what the budget allows. Then next I'm starting here on the Z-axis assembly. I'm just kind of doing all the sub-assemblies first until I build it up into bigger things. So here I have just the gantry plate, and then I'm mounting up top the motor and everything. Here I have to take it off again as the connectors are too big to fit through. So just take it off again, and you can also see that I'm using some corner brackets in the back to reinforce it. Here we have the linear rails for the Z-axis. These are HT 15 size compared to the 25 size for the X and Y axis, but this will be plenty strong enough for this here. Now what I'm using here are Hewin rails, however I did not purchase them directly from Hewin, but from an AliExpress site, and they, like by all appearances, comparing them with some articles online, they do appear to be actually genuine Hewin rails. However, they did not come with a certificate, so I'm pretty sure they are kind of sold out the back door, or maybe they didn't quite meet the quality specifications or something, but they were also like almost half the price compared to like directly from Hewin, which was just out of sight of the budget. I will have them as well as all of the other AliExpress products that I bought linked down below. There will be affiliate links, so it really helps me out if you purchase through them. Even if you decide to go with a different product, if you use that link, I just get a small kickback, and that really helps making all these projects possible. When mounting the rails, I just kind of try to align them for the longer Y-axis rails here. I align them to the profile itself, just using a dial indicator, and this is reasonably straight. Now you do want to keep in mind that these rails are not designed to be perfectly straight on their own. They're designed to be constrained, so you do have to tram them in like this to make sure that they actually run perfectly straight. Here you can also see why I chose to go with aluminum extrusion over something that might prove more damping or structural rigidity, like some concrete reinforced just tubing or something like you suggested. But here I can just simply insert T-nuts and get all of this screwed in place and squared up really quickly. And these aluminum profiles are also remarkably straight. Now, they're not perfectly straight. If you precision machine something, it will be better, but getting something of this length precision machine is really expensive. So these extruded aluminum profiles are a really good middle ground, and for a hobby machine, perfectly good enough. I got all of these profiles from Roderick, so the same people that made the Killer Bee, and also offered these profiles as like a full kit, the Stronghold Pro. I paid for them myself, but they did give me a little bit of a discount, so I will have them linked down below in the description as well. Moving on to the x-axis, I make sure that the 3 profiles that I'm using to connect here are like nicely butted up against each other, and also that they are perfectly in line with each other. That's why I'm using the straight edge here and some feeler gauges to make sure that the 2 faces that I will later mount linear rails to are actually on the same plane and not kind of askew to each other. The first rail then I'm just aligning to one of these profiles, and then the second one I will later align to the first one. It's really handy to have one of these magnetic indicator bases. You can just magnetize that to one of the sleds and then move along the axis and just go ahead, tighten one bolt at a time, kind of in intervals, and that makes quick work of aligning everything. At this point, I also added some holes to route the end stops, which is it's just a lot easier to route them through the profiles here, which I will not have access to anymore later, which is why I'm doing that now. This will just route the cable very cleanly through the profiles, and it comes out the other end where then I have the drag chain where it goes into. I did have some small issues with these machine ball screws, as there was a little bit of a burr left on some of the machining and the bearings, and the machine surfaces of like the end machining were very tight, which is a good thing. However, that meant that I had to do some filing on some of the places to get the burr off so that they actually fit into each other, as I had like a really hard time getting all the bearings properly seated. I think I also miscalculated the length of these ball screws somewhere. I didn't get them custom machined to the right length, which most sellers on AliExpress will do at no extra charge, so make sure to actually make use of that instead of just the pre-determined lengths. But I must have messed up somewhere in my calculations. At least I had to flip around some of the bearing blocks to be able to actually fit them in the right length. But luckily that was easy enough, and the floating side, as the name implies, the bearing is kind of just floating in there, so there is some adjustment room back and forth to make sure that everything is nice and tight. Then the ball screw nut adapter blocks I had actually ordered, but once again I must have messed up, or the AliExpress seller messed up, I don't actually know. But in any case, I decided to just machine them myself, as it seemed like an easy enough part to machine. And it would have been, had all the material on hand still as leftovers, but somehow it really kicked my butt, and I spent, instead of the like 40 minutes I expected to spend on it, I spent like almost a day on it, and the end result was kind of crap. But it worked out. The main problem was work holding, as before I was machining large flat parts, which was very easy to like work hold with double-sided tape or like masking tape and super glue trick. But these parts were kind of much smaller and didn't really want to work hold like this. So it was an absolute nightmare in retrospect. I should have just ordered new ones and waited the 2 weeks or whatever it takes to deliver. At this point, I also decided that the 3 extrusions here should probably be tied together a bit more than just at the ends, as otherwise the 2 linear rails wouldn't really be connected properly. So here I'm just drilling some holes spaced 40 millimeters apart, which is the pitch of the extrusions I'm using. These will create some straps to tie them together at the back. It's just some aluminum flat stock from the hardware store that I had laying around. I also ground the tabs off of some corner brackets, which allows me to use them like 90 degrees to how they're intended to. You can get the other corner brackets that don't have these tabs, but for some reason they are a lot more expensive. So it was easy enough, since I had these in hand, to just use the belt grinder here to grind off these flats. And then I'm just tying them into the extrusions, nice and easy, and roughly equally spacing them out. Doesn't have to be very precise, just want to have all of this tied together, and this should create a very rigid and structurally sound X-axis here. I at this point also go ahead and mount the Leadshine Servo for the X-axis, same as with the other ones. Just mount it in place, and I just kind of loosely tighten all the bolts, as later when I attach the belts I will have to properly tighten and tension the belts. Then I mount the Z-axis onto the X-axis for the first time, just kind of get everything lined up. I was intending to use that to tram in the second linear rail, which works, but I had just a bit too much play to where it wasn't really properly defined, so I instead used the dial indicator riding on one rail and indicating against the bearing surface of the other rail, and this was probably even more precise than doing it the other way. Then attaching everything and making sure that it is properly squared. I don't really have a good way of this, but it kind of self-located it, and we'll see in the end if it is properly squared. Otherwise I will have to loosen them up and square it up once the whole machine is done. And then we have first movements, just using a hand drill here to turn the lead screw, and as you can see, it moves back and forth. Here you can see me adding these tiny little MGN7 rails. What these are for is for the dust shoe that will later move independently. I will have a dedicated video about that much later, but it was just easier to mount these now. Now, they're really finicky to mount, and the biggest pain is that they are using M2 bolts, which are just tiny. I snapped so many drill bits and tabs, but in the end I got probably 2/3 of the holes actually with a screw in. But since this is just to kind of have a like motion guide and not for anything precise, it doesn't really matter as long as it holds. Then finally it is time to start with the main assembly of the frame. The spot where the killer bee used to be is now free. I managed to get that off to a nice new home, and I'm starting off with the base frame, just kind of getting everything into place, the two Y-axis modules assembled earlier, and then assembling the frame here with just these corner brackets. Now, the best way to assemble these ones would have been to drill through the profiles and then tie it in that way with bolts. I ordered all the extrusions tapped, so I could have easily done that, but that would have been a lot more work. And so for the sake of simplicity and getting this project moving, I'm just sticking with these corner brackets. But if you want to do it more properly and have some more time, you can definitely drill the profiles and tie them together that way. Both work perfectly fine. Then the main part here is just getting everything nicely squared up, aligned, positioned exactly like it is in the 3D model. I'm referencing the 3D model and just kind of roughly getting it aligned. And the main thing that actually has to be perfectly level and at perfect right angles to each other are the two surfaces where the linear rails are attached to. The trick I'm using to get these aligned without a very long straight edge is using a precision machinist level, and this way, by having the table roughly level underneath, which doesn't really matter, I just want a good reference surface, I can make sure that all of the individual surfaces are also level. And if everything is level in both directions, then I know that it is also parallel to each other. This is a lot easier to ensure, as I can just place this level everywhere, trim it, and then screw everything down. And in this clip you can see just how precise this level is. The bubble here is ever so slightly off, and then I add just a sheet of printer paper underneath the extrusion on one side, which means the thickness of this printer paper across the length of like 1.50 meters is what creates this big difference in the bubble. So you can really precisely line everything up this way, and way more precisely than I would be able to do it with any other method. It is a lot of back and forth, tightening everything does change it, and I didn't properly level my table beforehand, so that was probably the first mistake. But I did, after a while, manage to get it to where the two reference rails are all perfectly square, parallel, all that good stuff. Then the bed just wants to be roughly in the right place, but later I will be using a sacrificial spoil board, which will be surfaced by the machine itself. So if the bed is ever so slightly out of parallel with the rails, that will just be compensated for with the sacrificial surface. Then mounting on the gantry, I had some help from my dad to lift it in place and get it screwed in, just holding it temporarily in place with some wooden blocks, as this gantry turned out relatively heavy, just like the point where two people can lift it, but not something I want to hold in place too long. Then after getting that screwed in place, which I was very happy about how just easy it dropped into place, it just fit perfectly without any major issues, like all the holes lined up and there was no gaps. After this major success, I move on to installing all of the different pulleys and belts. The servo motors from Leadshine came by default with a key installed, which I will not be using for the pulleys that I'm using. They will just be held in with a set screw. So I'm using like M3 bolt here to drive out the key. The key is very stuck in there, but it has a thread for a M3 bolt that you can thread in to then pull out the key. That is a very elegant solution and works great. With the key removed, I can just simply add these HDD3 belts and pulleys. They are, once again, probably the minimum size I want to be using, but I think for the 400 watt servos, they are still perfectly fine. I'm using the 15mm width here, and that should hopefully be fine. I used the same trick on my Killer Bee for the X-axis as well. Later in the servo tuning, hopefully all of the kind of elasticity that these belts introduce compared to having a just direct rigid drive on the ball screws will hopefully be tuned out in the servo tuning, which we will do in a future episode. I'll walk you through all the detailed steps of the Leadshine software that allows you to automatically tune everything. That's a great advantage of going with Leadshine Servo Motors instead of just some generic brand where you have to manually kind of play around with the settings. The servo tuning software is like basically the game changer that actually makes it an advantage to have servo motors over just regular stepper motors or closed loop steppers. If you don't tune your servos properly, you might as well not have them. Then the same story for the Z-axis, and I do have to admit it took me a couple tries to get the belt length correctly. I calculated them the first time and I got the Y-axis correct, but somehow the X and Z-axis I got completely wrong. And then I recalculated everything and I got the teeth count correctly, but somehow I managed to order 10mm instead of 50mm belts. So that's why I have 10mm belts on there right now. I ordered the correct ones and I will be replacing them in the future, but they just have not arrived yet. Then as a last part for this video, I'm going to install these drag chains, and I need a bit over a meter for the X-axis and like almost 2 meters for the Y-axis. So I just ordered 3 times 1 meter. I could have probably just gotten them custom length to what I needed, and that would have saved me this trouble, but I didn't want to bother with that, so I just ordered 3 times 1 meter, and I'm combining them, these 3 individual drag chains, into 2. You can also see that I went with fully closed ones. That is because on my Killer Bee I ended up with a bunch of chips all built up inside of the drag chain, which is not really fun and probably not good for the cables either. So I went with fully enclosed ones here, which were quite a bit more expensive, especially on the shipping front, but I think it should be worth it. They are also quite large compared to the ones I have on my Killer Bee, but there's a lot of pneumatics required for the automatic fuel changer of the spindle and all the other cables. All the servo motors have 2 cables, of course, so it adds up quickly how much space you need in your drag chains. I will later have some proper channels where they ride in, but for right now they're just sitting here. And I get them screwed into place and start feeding through the wires. For the first ones, I just kind of feed them through by hand, which is a bit of pain, but then I also pull a pull cord through, which will allow me to, for the future cables, have something to pull on and push from both sides, which makes it a lot easier to feed the cables through. Without a pull cord, you basically have to have the drag chain in a straight line, otherwise it's almost impossible, or without removing a bunch of the covers. But that's a bit of a pain on these close ones, so I wanted to avoid that. And it's just a lot of wrangling to get all of these cables fished through. I don't have quite all of them fished through yet, but I started with the just motor cables for the servo motors here. These were also provided by Leadshine. The cables are already terminated on both sides. On one side they have this special connector that screws into the motor, which is very easy to use and a very solid connection. And on the other side they're also already terminated to go directly into the drivers, so that will save me a lot of time on the wiring front. To mount a drag chain onto the gantry, I'm just using this 3D printed adapter here. I think this should be plenty strong enough. I printed it with a bunch of perimeters, and this is just a lot easier to attach it than to custom machine a bracket for this. The loads are not that high on it. Then here you can see another shot of installing the cables on here. So you just kind of snap the connector into place, and then there's a couple of screws that hold it in place. So this is a very firm connection, but easy to kind of remove. Then with all of the motor cables pulled through, you can see me wrangling here with the spindle cables and all the pneumatic hoses. I first tried to do it all at once, which did not work, but then I started with just the spindle cables and then the pneumatics, and that worked out, but it still was quite a bit of wrangling. But you will see more about the spindle installment in a future episode, just like I will talk more about tuning the servo motors and installing all the electronics. So I'm not quite sure in which order the next episodes will come out, but they will be here on this channel, of course, and should hopefully come out fairly soon. I think now everything should move quite a bit quicker. So with that, once again, a big thanks to Leadshine for sponsoring these motors. Big thanks for you for following along with this episode, and make sure to like, comment, subscribe, all that good stuff. Leave any questions you have down below. I will definitely be in the comments and maybe answer them in a future episode if something bigger comes up. So with that, thank you guys for watching, and until next time.